Okay, question 19. A polygon has n vertices where n is greater or equal to 3. It has the following properties. Every vertex of the polygon lies on the circle. Alright, so every vertex bang on the circle C. The center is inside a polygon, such that, you know, your points can't be only on one side of the circle, I suppose. And the radii from the center to the vertex cuts the polygon into n triangles of equal area. Okay, so lots of words, right? So, which of values of n are sufficient to deduce that the polygon is regular? Okay, so, too many words. Let's draw a diagram to visualize this, okay? So, picture, okay? Okay, so, well, why am I drawing some axes? Because there's no coordinates here, so I don't know why I'm drawing some axes, but I meant to draw a circle, okay? Okay, so, let's imagine n is equals to 3, right? Let's use a simpler scenario first. So I'm going to draw a really random triangle, random scaling triangle, okay, to make this as general as possible. So I'm going to pick some random points which hopefully don't look like any sort of triangle. Where should I pick the last point? Maybe here? I don't know. Okay, so something like this, okay? And then now the center will be here. Cool. So, and then I'm going to chop this into 3 parts. Okay, question becomes, well, are the areas equal? Well, by inspection, they don't seem to be. Yeah, so we know that the area of a triangle is calculated by half AB sine C, right? And each of these triangles, they share the radii. All right, so the A and B must be the same. It's just that the angle is just different. Yeah, so if I guarantee that the sine something is, you know, if the sine something is the same, then I'll have the same area, right? Okay, so therefore the only way that you can do this is that you evenly distribute the angle here, right? As in 120, 120, 120. That's the only possible way that you can do it. Right, 120, 120, 120, which leads to 30, 30. Yeah, right, 30, 30. And then 30, 30 again, then you get an equilateral triangle, right? Then you get an equilateral triangle. So n equals to 3, it is sufficient, yeah? The 120s in the middle is the only way that you can do this. All right? Okay, then we got to ask, naturally, what is n equals to 4, right? What happens when n equals to 4? Okay, so let me scroll down a bit to make myself some space. N equals to 4, God, what am I doing? Okay, like this. All right, so I could easily think of counterexample actually already in my head. You could draw a rectangle, no? Rectangle, and then you start from the center, you go dot, 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 and then these triangles have equal area. If you're not convinced, then you can chop the chop the rectangle into 8 parts like this, right? And then each triangle has 2 parts, so they have equal area. All right, so for n equals to 4, I found a counterexample straight away. Right, so it's insufficient to deduce that the polygon is regular, right? Because it's not a square. Okay, so if I keep on doing this, right, it's going to take ages, right? Because of course n can go to infinite, right? So that's not very good. So let's try to generalize this, okay? So if I want to make sure that sine something, sine a certain angle, is the same value, then I either have theta or I have 180 minus theta. Correct? I either have theta or 180 minus theta because of the symmetry of the sine graph, right? These two things would give the same sine value. Okay, so what can I do? Well, suppose I have, some angles of theta and some angles of 180 minus theta. Yeah, suppose I have k angles of theta and I have n minus k, therefore angles of 180 minus theta, right? Because all of them have to have equal area, right? And of course, if you have n-sided polygon, you will chop yourself into n triangles, right? So you have n angles in between. So if k of them is theta, then n minus k of them, so the rest of them, would be 180 minus theta. Yeah. Okay, so what are the possible values of k? K could be 1, well, k could be 0, but that's silly. If k is 0, actually, that's just an equilateral triangle, right? If k is 0. So we consider k is 1, k is 2, k is 3 is also possible. K is 4 is an interesting situation. I think k is 4 is not quite okay, right? So, well, let's just check why that is, all right? So, I know the angles at a point, k times theta plus n minus k, 180 minus theta, equals to 360. All right, because the angle's at a point, right? Or the angles must sum to 360. Okay, so let's imagine when k is 1. Okay, when k is 1, theta equals, theta plus n minus 1 times 180 minus theta equals to 360. All right, cool. So I just need to check, really, because if you look at the options, I just really need to check n equals to 5, right? Because if I can prove to you that n equals to 5 works, or is sufficient, then I'll answer option D, right? Because now I know that it's not A, because n equals to 3 is a value. B is possible. C is no good, because I showed you a counterexample of n equals to 4. E is no good, therefore, counterexample n equals to 4. So I'm deciding between B and D, right? So if I show you that n equals to 5 works, or doesn't work, then you'll choose D or B, respectively. All right, so suppose n is 5. If n is 5, then this is theta plus 4 lots of 180 minus theta equals 360. Therefore, 360 degrees equals to 3 theta. That means that theta is 120. Yeah, theta is 120. Good. Okay, so if theta is 120, that means that this is 60. Yeah, the 180 minus theta will be 60. So I have 5 triangles with the combination of angles 120, 60, 60, 60, 60. All right, so 4 60s there, and somehow it's lagging a bit, so my apologies there. Can't write really well, but 4 60s behind the 120, okay? And this adds up to 360, all right? And all of them have the same sign value, so therefore they will have the same area as they share the same radii. So n equals to 5, it's possible to construct such a thing. All right, although I didn't draw the picture out because it's quite hard to draw and my art skills is very limited, but mathematically it works, right? So this is non-regular, of course, because the angles are different. So it is insufficient for n equals to 5. Yeah, it's insufficient for n equals to 5, so D is wrong. Final answer would be B.